Okay, I know that you're all working really hard on factoring differences of squares. This is not a very difficult concept. It's a really kind of easy pattern to follow. You just have to be looking for it. So let's try this. In symbols, it just says this. It says that a squared minus b squared, this is a b, is equal to a minus b times a plus b. As an example, x squared minus 9 is the same as x plus 3 times x minus 3. Let's look at why this is true. It's not really hard to see. So let's just try to follow this if we can. It's just going to do FOIL. X times x is x squared, isn't it? And then we're going to do x times negative 3. This is where the pattern starts to help. X times negative 3 is negative 3x, right? But look what happens when I do this. 3 times x is positive 3x. And positive 3x minus 3x is 0 x's. 3 times negative 3 is negative 9. So that's the pattern. Let's write it out together and see if we can see how this worked out. So here I have FOIL set up, right? It's this piece right here times everything over here. Whoops. Oh, this piece here times everything over here. Then this piece times everything over here. So let's do this thing kind of one at a time. We do x times x is x squared, isn't it? Then x times negative 3 is negative 3x. This is the part that I want you to see. This is what's happening here. X times negative 3 is negative 3x, isn't it? And then 3 times x is positive 3x, right? And then 3 times negative 3 is negative 9. So what happens here? Remember that we said this thing is going to turn out to be x squared minus 9, right? Look at this for a second. Negative 3x's plus 3x's is, well, no x's at all. They cancel out. And we have x squared minus 9, right? We have x squared minus 9. See that? Because these two pieces canceled out. So that's why it works the way it does. Let's try to look at some examples from the book. This one is just a relatively simple one, and we want to factor this. So let's factor this. We're going to factor all of these, so let's this be our statement the whole time. So we're going to factor n squared minus 25. The way you need to kind of see this is this. N squared is, right, is n squared minus, look, 5 squared, isn't it? So we can use this pattern now up here, and we can do n minus 5 times n plus 5. Somebody asked me the other day, does it matter which one is plus, which one is minus? Of course not. The order of multiplication doesn't matter, right? 7 times 5 is 35, and 5 times 7 is 35, so order doesn't matter. And look, this would work out the same. N times n squared. N times positive 5 is positive 5x. Negative 5 times n is negative 5n. When we subtract those, we get 0n. Negative 5 times positive 5 is 5, right? 0. Okay? So right now we're not finding solutions, but we could certainly talk about the solutions next if you wanted to. Here's another one, which I think is even, so let this be number 1, and let this be number 2. So our second example would be this. 36x squared minus 49y squared. So we're looking at this. Here's what I'm saying. 36 is a perfect square. X squared is a perfect square. 49 is a perfect square. Y squared is a perfect square. And we have a difference, right? That's this right here. So the way I'm looking at this is this. I'm looking at 36 as 6 squared. And I'm looking at x squared as x squared. Right? And we can just rewrite that as 6x squared, because this x will distribute from here to here, so this will go to 6 squared, x squared, right? So how do you think I'm looking at this? This negative sign is this one, so how do you think I'm looking at this 49? And this y, right, is going to be 7y, isn't it? Squared. Why is that true? Because 7y times 7y is, 7 times 7 is 49. Y times y is y squared. Isn't that true? So when we factor this out, we get 6x minus 7y times 6x, right, plus 7y. Good job. Very good. So not terrible, right? Again, order does not matter. Order does not matter at all. So let's try another example. Where's my work? There it is. So let this be example 3. Example 3. Look at this. This is terrible. 48a cubed minus 12a. And you're saying, well, I thought we were talking about difference of squares. This is a cube. I know. But if you know you're looking at that, if you know you're looking for this, it might help a little bit, right? So first thing I'm going to look at here is, what is the greatest common factor? I'm going to start factoring that out. So the greatest common factor of 48 and 12 is 12, isn't it? And what's the greatest common factor of a cubed and a to the first? And remember, it's the lower of the two numbers. So the greatest common factor is the a to the first. So a to the first times what? 4a squared. And 12a times what is negative 12a minus 1. Hopefully what we're seeing is this, right? Hopefully what we're seeing is this. We're looking at this and we're like, you know what? Oh, here's our difference of squares right inside there, isn't it? So we go back and we factor this out. This is difference of squares. This is the same as 2a squared. And negative 1 is the same as 1 squared. It's kind of a weird one though, isn't it? Okay, so what are our factors going to be? First off, we have to keep the factor we had. So we have the 12a here times 2a minus 1. You know, in the last we did minus. Let's do plus 1 here just to show you that it doesn't matter what order you put them in. 2a plus 1 times 2a minus 1. Okay. All right, so these are the factors. Remember, these are factors, not solutions. These are factors. All right, let's see if we can get through. Here's another one we can do. It's kind of on the same idea. So let's use this as example number 4. Example 4 of factoring differences of squares. We have 2x to the 4th. That looks kind of weird because x to the 4th here, minus 162. So what I'm going to do here is, guess what? Right. Look for the greatest common factor. Greatest common factor is just 2, so I take the 2 out and get x to the 4th minus 81. I'm wondering if you can see this with me. And this is the way I'm seeing this is I'm seeing this as 2 here. And then look, x squared minus 9 squared. Whoops, wow, that was bad. That is 9 squared. So what would we get as our answer here? We would get 2. This is our difference of squares here. Here's our factor, so it's x squared minus 9 times x squared plus 9. And this one gets kind of weird here because look, we get another one out, don't we? This one can be factored, so we get 2. And this one is, see if you can figure this out, x minus 3 times x plus 3 times x squared plus 9. I know that this right here, this is a square and this is a square, but it's not, right? It has to be difference. So that's not a negative sign. So that cannot be factored. We'll talk about what that looks like later, but this can't be factored, okay? So excellent work. What you need to do is practice, of course. So practice, practice, practice. Practice.